Okay, so I'm going to look at some of section 2.8 questions that's on your MyLabs math program. Kind of work you through some sample problems there. So if you'll notice, number 1 has an f of x, and yours will be a little different, regenerated values, but I'm going to use f of x equals x plus 3 and g of x equals x squared minus x. Basically, what I would just tell you in general about this section is you can add, subtract, multiply, divide, and do a composition of two functions. So we could add these functions together. We could add the parts that we can combine. We could subtract. We can multiply. We can divide. And then the other thing, and we'll get to in a minute, is called a composition, where you put a function within a function. So that's kind of basically what section 2.8 is about. Now, if it just says do f plus g, and it leaves an x there, which I notice most of your practice problems have a number in place for you to actually work it out. I'm trying to see if there's any just left with x in it, and I don't think I assigned any of those. But sometimes they do just leave an x in, I guess, in other math problems that I didn't assign, where you just add the two functions together. So x plus 3 plus x squared minus x, and then you can combine your like terms. Notice these x's cancel out, and then you would have the f plus g of just leaving it in terms of x. But I notice I have a number assigned for your homework, and so for example, they put a number here like -6. So that means if there's a number, you're going to plug that number in for the x. You can work it all the way out and just get a numerical answer and not an algebraic answer. So whatever number is placed in that parenthesis, that is your x value. You can add them first and then plug in the -6. Or we could have plugged the -6 into the x's and worked it out without the algebra first. I'll demonstrate that. But anyway, then I can work it on my calculator or by hand. That'll be -6 squared is 36, making 39, the final answer there. Notice I would have got the exact same answer if I would have done these individually. I could have worked f of -6, put -6 into function f, and had -6 plus 3, which is -3. And then done g of -6, put -6 in for these x's, that'll be -6 squared minus -6. Work that out, that's 36 plus 6, or use your calculator, and that's 42, and then add the two answers together. Still the same answer of 39. You can do it individually, plug the -6 in for the x's, work them out first, and then add them. Or what I did first is I did the algebra, function f plus function g, simplify it down, and then take that answer and plug the -6 in for the x. Either way, you can see it's the same output. Okay, then you do that for a few problems I notice here. That's the basis of it though. So let's do some more examples. Number 2, we have a different defined f of x. Yours will be similar. And then a g of x. In here. Okay. Then it says to do f minus g, and then it plugs a number in here of -4. So you're going to subtract f minus g, and then plug in -4. That's one way to do it. Or, like I said earlier, you can plug the -4 in for the x's there, and then subtract the two answers. Either way, same result. I'm going to do f minus g. I'm going to do it algebraically first. Take function f, subtract function g. Since there's two parts, that'll distribute my negative sign, and that'll make it a plus 4x and a -6. Then you can simplify the 3 and the -6 will be -3. So you can do the algebra first if you want to, and then plug in the -4 for the x's. And from there, it's just use your calculator, carefully type that in, and that'll answer that. Let's see, just so I'll have it, that is 64 minus 19, what is that, 45? You'll work your way all the way down to an answer, 45. Number 3. Number 3 is similar, only we're going to multiply this time. So just various operations on functions. Add, subtract, multiply, divide. So here we define function f as x squared minus 10, and function g as 14 minus x. and the directions say FG, which means times. There's no symbol between it, so it's F times G, and then a number is given at 8. So again, you can do the algebra first. F times G would be x squared minus 10 times 14 minus x. I don't know that we want to do that though. That'd be maybe harder on this one, but we could multiply that together, do the algebra first, and then plug in the 8. But I think it's going to be easier, just plug the 8 into the x's and work it out that way. So 8 squared is 64 minus 10, which is 54. And then we plug the 8 into function g, and 14 minus 8 is 6. And then it says multiply those two answers. So 54 times 6, whatever that is your final answer, 324. All right, then I notice on number 4, it's more visual. Instead of giving you the equations to plug in for, it's the same thing, but it's a visual representation of the equations. So we have the visual or the graph of the two functions. So we have a function f that looks like it's a parabola, f of x. Then we have a line through that, and that's function g. So instead of giving us the equation, they gave us the picture of the equation, the graph. Then it says to do f plus g, f minus g, all the different composition questions there. So it'll be better if you have graph paper or the paper on here and can kind of see more specifically to count where these are at. But just so you know, like if I'm doing f of 0 means go to function f, which we said is the parabola one, and then go to x is 0. At x is 0, what is the y value? It's saying if this is 0 for x, what is its y value at that point? And its y value is also 0 there. So f of 0 would equal 0. If I do f of 1 equals, f of 1 means go over to x is 1. So at x is 1, where is the graph? The graph is this parabola shape. So when I go over 1, how far up is the graph? And looking at you might have to look at the one that's on your screen. On my screen, on my graph paper, when I go over 1, it's up 1. So over 1 for x is up 1 for y. So the answer to that would be 1. They're not always exactly the same like that. Let's do something different, like f of 2. F of 2 means go over to x is 2, and then count up to where it hits the curve. And on my paper, it hits the curve at 4, at y is 4 places up. So when x is 2, the y value is 4. So that's what that means to do that. And then on these, it has 2 added together. So it says do f plus g at 0. So do that graph f and do graph g, and then either add or subtract, multiply, or divide your two answers. So let's do that. Example A is f plus g at -2. Again, this is always your x value, so if we go back 2 places, it wants you to find the y values and add them together. So where it hits the f graph, it's should be up 4 places. So f of -2, that's 4 places. And then do the g graph. Back to, how far up is it? On my picture, we need some graph paper here, don't we? So when I'm back 2, it should be up 1 on my picture. Back 2 places, that y value is 1 places. So when I do f of -2, the y value is 4. When I do g of -2, the y value is 1. And then it says add those two answers, which would be 5. And that's the concept. You'll do the 2 graphs, find their y value at this x value, and then you add, subtract, multiply, or divide. So then the next one, I'm subtracting f minus g. Say I'm doing f minus g at -2. From our work above, we found f of -2 already is 4, and then g at -2, when I go back 2 places, it was up 1 place, so that's 1. So I already had those. This time it says to subtract those 2 answers. So we could add, subtract, multiply, or divide, whatever it indicates there at 3. So that's the idea there. Let me move on to another type of problem. So number 5 is using the function formula we've got here. Number 5, it says find f, if f of x is 4 minus x, it's got an ABC part, find f of x plus h, and then we'll go on after that. All right, so let's talk about what f of x plus h means. This means on function f, which we're just working on this 1 this time, function f, we want to plug in, instead of x, this is always where our x value is, plug that, whatever's in this parenthesis, it's what you plug into the x value. So it'll be 4 subtract, instead of x, we're plugging in x plus h. Again, whatever's in this parenthesis, this is f of x notation, that's what we plug in for x. It's a little nicer when there's just a number there to plug in. Like if it said f of 1, I would have said 4 minus 1, 3, and been done. But it gave me this algebra to plug into x. All right, we can simplify that by distributing the negative sign, and that's all we can do on A part. So that's the answer to A. For B part, it builds on that. It says f of x plus h minus f of x. So we just did f of x plus h. We have that answer. Then it says subtract the function f with x in for x. So don't change it. Just leave it as it is. Here's f of x. 4 minus x. So we can clean this up a little bit by distributing your negative sign. And then combine any like terms. The 4's cancel each other out. They add out. And the negative x and the positive x cancels out, leaving just a minus h. Then on C part, it takes it one step further and has, this is actually an entire formula called the difference quotient. They use this in the calculus class a lot, so this is kind of a precursor to using that, but it is along the lines of what we're doing, so it fits in nicely here. Notice we just did that in B part, the numerator here, and got negative h, and then the rest of the formula says divide the answer by h. The h divided by h cancels out and leaves a negative sign, or a negative 1. So the final answer to that is negative 1. Now this formula is actually, again, called the difference quotient. It gives you the slope of the tangent line along any curve. Well, because our original equation started out as an actual line, it follows through that the slope of a line is just in front of the x, negative 1. And notice this formula, it's kind of a fancy slope formula, but it gets you to the slope of your figure. If it's just a line, the slope is always and forever the same slope, negative 1 in this case. But when we do the next example, number 6, it is not just a line. Let me erase this and do the next example. It's not just a line, so the slope is changing along the curve. It's actually a parabola. Anytime you have x squared and the y equals a quadratic, it's going to be a parabola. So the slope is different depending on where you are on the curve. So we're going to get a little more action on this one than just one number. So to start it out, we plug in x plus h for any of the x's. This is going to look like x plus h squared plus 6 times that's x plus h plus 2. That's a little complicated algebra, I would say. To do this, you need to FOIL this out. X plus h times x plus h. Since it's squared, it's going to give you an xh for the outer, and an xh for the inner, or 2 xh's. Then the last times last will be h squared. We also need to distribute the 6, and then combine, if there be any like terms, combine them. But actually, nothing combines on A part, so that is your answer. B part, then the second part of the formula, takes the x plus h. It says let's see, f of x plus h. I think I was supposed to have had that up here. We're doing f of is the better notation, not f of x equals. Sorry about that. F of x plus h, which is the first part of the formula, where we plug x plus h in for the x's. Then it says subtract the original function, f of x. So we take all of this stuff we just did, our answer for A part, then we subtract f of x. When we subtract f of x, it'll change all these signs. So to save time, I'll just change all those signs to their opposite because of the subtraction distributes. Then on this step, some things should cancel out. Notice the x squareds cancel, the 6x's cancel, and the 2's cancel. And so all you're left with is terms that have h's in them. And that's good because in C part, the last step is you take that answer from B part, and the last step is divide by h, all of the answer by h. So one of these h's cancels in all these terms. one of these h's, you still have an h left there, and then that h disappears, leaving 2x plus h plus 6 for your final answer to that.